We are using the vector components from magnitude and direction. So they're giving us the direction of the angle and they're giving us the magnitude. And we'll use those to find the x component and to find the y component. Okay, so it really helps to kind of have something to remember your trig functions, what's your x and what's your y. So I think about tangent for me, and this is my side work. Okay, so this helps me organize what I'm dealing with. So tangent of theta is sine over cosine. So I always remember that. So that's how I remember it, sine of theta over cosine of theta. And this is just like slope. Tangent is like a slope idea. Slope is your y change and your x change. So what that does for me is it lets me know that sine corresponds to y, cosine corresponds to x. Okay, so I use that information to kind of help me with each one. So the change in x is going to be your magnitude. So the change in x is going to be equal to the magnitude of whatever vector we have. So in this case, it's vector u times the x component, with the x component is cosine. And then whatever the angle they gave us of theta. All right. The same idea, I'll do it over here. The change in y is going to be equal to the magnitude of whatever vector they gave us times the y corresponds with sine, times sine of theta. And theta is your direction angle. Okay, so we're just plugging those in, and then that gives us what the change in x and then change in y is. Okay, so change in x is equal to 6 is the magnitude. That's nice and easy. Cosine of theta is 120 degrees. So we're in degrees here. Be careful about that. Do they give us a calculator? You might need a calculator. And they want nearest hundredth here. They want round your final answer to the nearest hundredth. And that's the key. All math, you never round during your math. You always round at the answer at the end. All right, so we want 6 times cosine of 120 degrees. And we're in degrees here, so be careful about that. You have to end the parenthesis here, equals 6 cosine 120. What's the issue? Let's try it one more time. It's just cosine of 120. Cosine of 120, just trying to use their calculator, equals, okay, cosine of 120 is negative 0.5, okay, good, times 6. Okay, negative 3, so I got this as negative 3. So that would be the change in x part. And then I'll do the same thing for y. The magnitude for y, or the magnitude for our vector, is 6. And then we're doing sine of what's our angle? 120. We're in degrees here. Okay, so I'll go ahead and let's try that on the calculator again. I'm going to try it again. Let's see if it will let me do it. 6 times sine. So maybe I need to multiply. They don't like it next to it. Let's try that. 6 times sine of 120. In parentheses, I have to be in degrees. Yep, that one worked. So that is equal to, change in y, 5.1961 ... That's a 6. All right, and they want nearest hundredth. So 10 hundredths, that's the one I'm looking at. I go to here to round. So that is approximately equal to 5.1. That rounds up, so that's just 5.2, 5.20. All right, that's everything we need. So I got negative 3 and 5.2. And then just sort of makes sense. It's nice to check your work. Are we landing in the correct quadrant? Did we land where we needed to? So x is -3, 1, 2, 3. Yep. And then 5, 1, 2, 3, 4, 5.2. Yep. So there's our terminal end. Everything looks good. Got it.